Milan, today we're going to be doing exponents, and I'm simply explaining what an exponent is. An exponent is simply a number or variable multiplied by itself. That's where exponents arise, okay? They are normally given in this form. Please note that we have a name for 2. We also have got a name for 3, all right? 2 is called the base. 3 is called the exponent. It has 3 names actually. It's an exponent, index, or power. But normally when we talk about power, it is 2 and the 3 together. That will be your power, okay? The exponent simply indicates how many times the base has been multiplied by itself. Now, in the above example, you realize that 2 has been multiplied by itself 3 times. The first exponential law says that when multiplying the same bases, you must add their respective exponents. The question is, why is this the case? The underlying reason is the fact that there is a very close relationship between addition and multiplication. Now, if I have 2 to the exponent of 3, when I expand it, it will be 2 multiplied by itself 3 times, which is 2 times 2 times 2. Or you can simply say it's 2 to the exponent of 2 multiplied by 2, which is 4 times 2, and still gives you 8. Now, let's say we multiply the above by another 2. How many bases will we have multiplied? Note that you will be increasing the number of times that you're multiplying 2 by itself. So far, 2 has been multiplied by itself 3 times. So if you multiply that 8 by another 2, it means that you're going to be multiplying 2 by itself 4 times. Now, this is what we got here. That's why we have 2 times 2 times 2 times 2. It is 2 to the exponent of 4. As proved above, the multiplication of same bases lead to addition of respective exponents. In essence, if I gave you a, which is a base to the exponent of n, multiplied by a, which is a base to the exponent of 2n, I will simply write that as a single base. I will keep the base and simply add the exponents. That is why that will lead me to a to the exponent of n plus 2n, and that will give me a to the exponent of 3n. Similarly, if I've got a base of b raised to the exponent of n multiplied by a base of b raised to the exponent of m, that will be written as a base of b, and then you add the respective exponents. So your exponent will now be n plus m. Simplify the following to the simplest exponential form. Let's see if you understood what we did in the previous 2 slides. Here we are simply multiplying x to the exponent of 3 with x to the exponent of 11. And the next one, I'm just going to do the first one first, and then give you a couple of minutes to do the others, okay? So we have to simplify all of those. Try number 1. What do you think the answer will be? We have x to the exponent of 3 times x to the exponent of 11. What will be the answer in that scenario when you simplify that? The law of multiplication simply says that you multiply the same bases, you keep the base, and you add the exponent. So we will add 3 plus 11. What is 3 plus 11? It is indeed 14. All right, let's go to number 2. Remember, when you're multiplying terms that have variables, you start first by multiplying the numbers, all right? So we'll simply multiply which is the coefficients in this case. You will simply multiply the coefficient of y, which is 1, the first y, and the first factor is 3y. So the coefficient of y there will be 3, and the third factor is 4y. The coefficient there is 4, and the last one will be 2y. The coefficient is 2. You first multiply the coefficient first. You have done this under algebra in grade 8, okay? So I will simply multiply 1 with 3, with 4, and with 2. So 1 times 3 times 4 times 2, that will give me 24, all right? What about the y's though? Because you're multiplying the same variable, meaning that you're multiplying the same base, you will simply add the exponents. What is the exponent of the first y? The exponent of the first y will be 1. The exponent of the second y will be 1. The exponent of the third y will be 1. And the exponent of the last y will be 1. So I'm simply going to add all those exponents. How much will they give me? They will give me 4. So I will write this as y to the exponent of 4. Hence, my answer will be 24y to the exponent of 4. Let's go to the next one. Simplify that. What is the answer? Note that you're multiplying the same base, which is x, 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 all right? And the exponent of each of those bases is 1. So let's see, what will be your answer? It will be x to the exponent of 5. Let's go to number 4. Nothing has changed here. Note that we still have the base and the exponent. The first base here is 2, the exponent of that is 2, multiplied by the second base, which is 2, and the exponent is 5. The third base is 2, and the exponent is 1. For this one here, for the third factor, the exponent will be 1, and the last one, the exponent is simply 2. You write this as a single base, so a base will be 2, and then you just add the exponents. Let's just add the exponents. It'll be 2 plus 5 plus 1 plus 2. How much will that give you? 2 plus 5 is 7, plus 1 is 8, plus 2, it gives you 10. So the answer here, you write it as a single base because we multiply same bases, which is 2, 2, 2, 2. So you will write it as a single base, which is 2, and then you add all the exponents, and they will give you 2 to the exponent of 10. Let's move to the next one. So here, how do we simplify this? I will start by multiplying the m's first. So I will write that as a single base of m, but what will be the exponent of that m? The first m has an exponent of 1. Remember, if the exponent is not written, it is 1. The second m has an exponent of 1, and the last m has an exponent of 2. So what is 1 plus 1 plus 2? It is m to the exponent of 4. Now you do the n's. When you multiply the n's, what are you going to get as the answer? It will be n to the exponent of 3. That was great. Let's do this one here. What is the answer for this one? You're multiplying 3 to the exponent of 5 times 3 to the exponent of 1 times 3 to the exponent of 2 times 3 to the exponent of 3. That will give you keep the base, which is 3, because we're multiplying, and the rule is that when you multiply the same bases, you keep the base and you add the exponents. 5 plus 1 is 6. 6 plus 2 is 8. 8 plus 3 will give you 11. Hence, the answer here in simplified form will be 3 to the exponent of 11. All right. Remember, if the exponent is not written, if the base, you're just given the base, but you're not given the exponent, know that the exponent of that base is 1. Just like the second factor there. That 3 didn't have any exponent, but it does have the exponent. The exponent is not written and it is 1. Number 7. What do we have? It is m to the exponent of 15. You write it as a single base and then you add all the respective exponents. 5 plus 2 is 7 plus 1, that will give us 8 plus 7, that will give us 15. Do this one quickly. Here you first multiply the x's together. That will give you x to the exponent of 5. What about the y's? Remember, when you multiply the variables, you just bring them together. So the y's will simply give you y to the exponent of 5. So the answer will be x to the exponent of 5 times y to the exponent of 5. Let's try this one out. You start first by multiplying the p's, all right? You're multiplying the p's first. You will write that as a base of p. And then you add the exponents. Two plus 6 plus 7. How much is that? It is indeed 15. What about the q's though? I'll end up having p to the exponent of 15 times q to the exponent of what? 2 plus 5 is 7. 7 plus minus 6. 7 plus minus 6 is the same as 7 minus 6. Okay, 7 plus minus 6 is the same as 7 minus 6. Remember, it's 2 plus 5, which is 7. 7 minus 6 will give you 1. So the answer will be q to the exponent of 1. Because the exponent of q is 1, again, remember, we do not write it. If the exponent is 1, we do not write it. Let me just clarify this. If the exponent is positive 1, we do not write it. So if you are just given the base and there's no exponent given to you, you just know that the exponent of that base is 1. You don't say that it's 0, it is 1. If the exponent is not written, then it is 1. The only time that the exponent will not be written is if the exponent is 1. If it is 0, then it will be written. If it is -1, then it will be written. So the only time that the exponent will not be written is when the exponent is 1. Let's do this one quickly. Note that we are multiplying everything here. Start with the x's. What are you going to get? X to the exponent of 4. What about the y's? It is y to the exponent of 2. So it's x to the exponent of 4 times y to the exponent of 2. What about this one here? The base is 3, but now you have to add those exponents, and those exponents are nasty because they've got x's in them. Go back to what you learned earlier in grade 8. When you are adding terms that have variables, you can only add them if they are like terms. But when you add them, you just add the coefficients of those terms. And remember, like terms must have the same variable, and the exponents of those variables must also be the same. Okay, I won't complicate this that much. I will simply write it on the side. So we've got 1x. We're adding it with 2x. We minus 3x. What is the answer? So it's 1 plus 2 minus 3. That gives us 0. It gives us 0x. And remember, anything that is multiplied by 0 is just 0. So it won't just be 0x, it'll just be 0. So the exponent will be 0. So when we multiply these bases here, my base will still be 3, but the exponent of that base will be 0. 3 to the exponent of 0 is, it is 1. Note that any base raised to the exponent of 0 will be equal to 1. Any base raised to the exponent of 0 will be equal to 1. That will be discussed later on in this video. All right. Let's do this. My answer here is, obviously the base will be 2, but remember what I said in the previous video, you only add like terms. We've got x plus 5x minus 4x. Those are like terms. And those blue ones will simply give me, it'll be 6x minus 4x, that will be 2x. And then I'm going to add the last one. I'm going to add, so it'll be 2x plus minus 2. So 2x minus 2 will be my exponent. Because I can't add this minus 2 here, it is not a like term as the others are, okay? The others have x as a variable, and that minus 2 doesn't have the variable x. So we cannot add it with all the other terms, right? We cannot add it with all the other terms because there is no x in there. So we'll end up having 2 to the exponent of 2x minus 2. All right, try that one quickly. Remember I said to multiply the coefficients first, so you will multiply minus 4 with 3 with minus 2. That will give you how much? Minus 4 times 3 times minus 2, those are just numbers, those are just integers. It'll give you, okay, so you're going to have minus 4 times 3. How much is that? Minus 4 times positive 3 gives you minus 12. Good. So what is minus 12 times minus 2? Minus 12 times minus 2, when you multiply two factors with identical signs, they'll always be positive. So minus 12 times minus 2 will give you a positive answer, which is 12 times 2 will give you 24. So we'll end up having positive 24. And then you multiply the variable x. X to the exponent of 1 times x to the exponent of 1 times x to the exponent of 2. How much is that? 1 plus 1 plus 2. Because here we're dealing with variables, you keep the variable, which is the base x, you keep the base x, and then you just add the exponents. 1 plus 1 is 2, 2 plus 2 is 4. So we'll end up having 24x to the exponent of 4. What about the y's, the ones that I didn't highlight? It will be y to the exponent of 5. So our answer here will simply be 24x to the exponent of 24x to the exponent of 4, y to the exponent of 5. Let us look at this one here. What is different with this? What makes this one different, this particular problem different, is that in between we've got plus. That's where you need to follow BODMAS, which normally says brackets first. Before you get to addition and subtraction, we're going to multiply. So you will start first by multiplying, all right? So you will simply multiply. Now it divides this into two terms. Multiply the first term. So this is the first term, all right? Remember, terms are only separated by plus or minus, all right? So that will be the first term. And this will be the second term. Multiply the first term, the one that I highlighted in yellow. What is it? It is 2 x to the exponent of 4 y. And then you're going to have plus. You keep the sign, which is plus. Multiply the second term, the one that I highlighted in sky blue. It'll be 3 x to the exponent of 4 y. So basically, this is what we will end up having. Are you now aware that we are actually adding like terms? What makes them like terms? These two terms have the same variables, which is x and y, and the exponents of those variables are exactly the same. So they are like terms. Now, since they are like terms and we are adding, what is the process of adding like terms? Now, people confuse the addition of like terms with the multiplication of like terms. Note that when the terms are like terms, we keep the variables as they are. We do not change the variables. We keep them as they are. So our answer will have x to the exponent of 4 times y. We'll have x to the exponent of 4y. But we just add or subtract the coefficients. So you will simply say 2 plus 3. What is 2 plus 3? It is 5. Remember what I've just said to you? I've just said to you, you keep the variables the same. So my answer will still have x to the exponent of 4, and it'll still have x to the exponent of 4. The only thing that you do when you're adding or subtracting like terms, you just add or subtract the coefficients. So my answer here will be 5 x to the exponent of 4y. Try this out. Note that the same thing applies here. We're not multiplying a negative number, instead we are subtracting, okay? There's no multiplication there, so there's just subtraction. So you do what we did earlier on, you multiply the first terms first, and then you multiply the second term. The first term, what is it going to give you? P squared times P squared gives you P to the exponent of 4. What about the second one? P cubed times P to the exponent of 1. Remember that P has an exponent of 1 because we didn't write it. You will end up having P to the exponent of 4 minus P to the exponent of 4. These are like terms. So P to the exponent of 4 minus P to the exponent of 4. Our answer will have P to the exponent of 4. Then you minus the coefficients. What are the coefficients here? It is 1 as well as 1. And what is 1 minus 1? 1 minus 1 gives me 0. So I'll end up having 0p, right? We're pushing p here. So 0p will simply give you 0 because everything multiplied by 0. Okay, so that is why our answer is just 0. Next one. This is the second law. It is simply the exponential law of division. So when dividing powers with the same bases, you must subtract the denominator exponent from the numerator exponent. I repeat, the denominator exponent from the numerator exponent. This theory comes from the fact that division reduces the number of times the base is multiplied by itself. For instance, 4 cubed divided by 4 will give you 16. Note that 4 cubed is 4 times 4 times 4. So when you divide that by 4, it means that you're reducing one of the 4's and now in the numerator, and now you're left with 1 4. So that is why we're going to take the numerator exponent, which is 3 minus 1, because the 1 4 is the exponent, the 1 is the exponent of the denominator, and I will explain that later. So that is why we left with 4 times 4 and gives you 16. Here, dividing by the same base reduces the number of times bases are multiplied. As specified, exponents indicate how many of the same base do you have multiplied. Here, the number of bases multiplied is decreased. Hence, it makes sense to reduce the number of bases, as division by the same base resulted in less bases being multiplied. Now, let's try and simplify this. Remember, when you divide same bases, you will simply take the numerator exponent minus the denominator exponent. The first factor here will be x to the exponent of 15. The second one will be x to the exponent of 11. So we'll simply say the first factor is the numerator, the second one is the denominator. So you will simply take the 15 minus 11, which is your exponent, but you keep the base, okay? You keep the base, you just take the numerator exponent minus the denominator exponent. 15 minus 11 will simply give you 4. All right, try these ones. Number 2, you're dividing the same basis. This only works when you're dividing the same basis. Remember that. So you will keep the base and take the numerator exponent minus the denominator exponent. What is the numerator exponent? It is 5. So you'll simply say 5 minus 3. You keep the base, which is 3. What is 5 minus 3? So the base 3 will now have an exponent of 2. How did I get that 2? It is just 5, the numerator exponent, minus the denominator exponent, which is 3. You good? and that's why we get 2 squared. Let's try this out. What is the answer there? Start with the x's. 5 minus 3 will give you 2. So I'll still have a base of x, but I will take 5 minus 3, which will give me x to the exponent of 2, times y to the exponent of, times y to the exponent of 2. All right. This one is a little bit tricky because you couldn't just divide, you had to simplify the numerator. In the numerator, you've got different bases that you need to multiply before you can bring in the denominator. Let's multiply the numerator. We've done something like that before. Mn times m squared n. What will that give you? M to the exponent of 4 times n to the exponent of 3. Great. So in the numerator, I've got m to the exponent of 4 times n to the exponent of 3. Now, what will I do? Please note, guys, if you have the same base in the numerator multiplied and the same base in the denominator multiplied, and those bases have, and that base has the same exponent, just like here. N cubed is in the numerator and there's no plus in between m cubed and m4. So we can easily cancel out. Did you hear what I said? If two of your numerators are linked by addition and your denominators are not by addition, are linked by multiplication, and your denominators are linked by multiplication, and you have a base in the numerator with the same exponent as the base in the denominator, you just cross them out, and that will simply give you 1. Or you can simply follow this process that we've been doing. So you will simply write this as m to the exponent of 4 minus 3 times n to the exponent of 3 minus 3, which gives you 0. Okay, the first factor will be m to the exponent of 1. The second factor will be n to the exponent of 0. And n to the exponent of 0 is just 1. And anything you multiply by 1 is itself. That's why we have m. Let's get to this one here. Quickly do it. You started with the numerator. What do you have in the numerator? N to the exponent of 14. How did you get that 14? When you multiply the same bases, you always add the exponents. So you added 3 with 11. 3 plus 11 gave you 14. So in the numerator, you will have n to the exponent of 14. In the denominator, you have n to the exponent of 3. Now you're dividing the same bases. What will be your answer now? So it'll be 14 minus 3. What is 14 minus 3? You will end up with a base of n raised to the exponent of 11. Great. Do this one quickly. Remember, before you apply the exponential law of division, you start with the exponential law of multiplication. You first have to multiply your numerators and the denominators. What do you get in the numerator? X to the exponent of 8. Brilliant. And then y to the exponent of 8 will be in the numerator. In the denominator, you still have x to the exponent of 4 times y to the exponent of 3. Simplify that. What are you going to have? Now you apply the exponential law of division. 8 minus 4. So it'll be x to the exponent of 8 minus 4 and y to the exponent of 8 minus 3. This is what you got. So 8 minus 4 will give you 4 and 8 minus 3 will give you 5. That's why you have x to the exponent of 4, y to the exponent of 5. Let's go to the next one. Remember, you multiply the numerator first and then you multiply the denominator before you can apply the exponential law of division. What do you get? Okay, let me just give you everything. Do all of this. Just pause the video and give yourself 10 minutes. Okay? After 10 minutes, you can press play to see the solutions. I assume that you're coming back because you have done. So what do we get for number 7? You will simply multiply the numerator. So the x's will be x to the exponent of 3 plus 6 times y to the exponent of 3. In the denominator, you will have y to the exponent of just 3, which is 2 plus 1. Okay? Now you can apply the law of division. With the x's, I'm going to have x to the exponent of 9 minus 5. What about the y's? Because the y, the numerator is only linked by multiplication, the denominator is only linked by multiplication, I'm allowed to cross out the bases with the same exponent. You can only do this if between your vectors there is no plus or minus. I repeat, you can only cross out if between the vectors in the numerator there is no plus or minus. So if what you're given is not linked by addition or subtraction, you can cross out. Otherwise, you cannot do that. You can't even apply exponential laws if there's a plus or minus between terms. Exponential laws can only be applied if there is a multiplication or subtraction. And look for options, because there are options that you can simplify if you're given a plus or minus. Simplify for you to have to eliminate that plus or minus, okay? Later on, when you get to grade 10, 11, and 12, you realize that it's possible sometimes to cross out binomial factors and trinomial factors. Obviously, factors are simply two terms that are multiplied, right? In that case, you're going to have a bracket of binomial multiplied by another bracket of binomial divided by a bracket of binomial multiplied by another bracket of binomial. There you will cross out, but know that it will simply be linked by additions. And remember, in maths, brackets make a term 1, right? And when it's a bracket next to another, it means that they've been multiplied, right? So here we're going to end up having x to the exponent of 9 minus 5, and that will give us x to the exponent of 4. All right. What about number 8? What did you get for number 8? For number 8, you will have this, and your answer will be that. Note that 2 to the exponent of 3 is 8. So we will simplify that and write it as 8. And this will be your answer to number 9. I just want to go back to number 9 and simply explain something there, okay? It is with respect to b. All right. Are you aware that b in the numerator has an exponent of 6 and b in the denominator has an exponent of 13? What I did there to avoid having a negative exponent, I simply took the numerator exponent of 6 and I subtracted it from the denominator exponent of 13 because 13 is bigger than 6. So the rule that you need to learn, even though based on what I said earlier on, and I will explain why I do this later when we do other things, the rule when you have same bases multiplied, you always take the smallest exponent, you minus it from the biggest exponent, and you keep the base where the biggest exponent is. In this case, you realize that the biggest exponent is in the denominator. So I'll keep the base in the denominator and take the denominator exponent minus the numerator exponent. And that will give me b to the exponent of 7, because 13 minus 6 will simply give me 7. Or you can apply what I have taught you thus far, but note that you will have a negative exponent. So b will have a negative exponent, which is -7. Note that if the exponent is negative, you need to take it to the denominator. So you will simply take the base and the exponent to the denominator. For as long as the exponent is negative, you just take the base and the exponent, and you get rid of the negative. The base and its exponent, you just take it to the denominator and you get rid of the negative, and hence you'll end up having the same answer, which is b to the exponent of 7. All right. For number 10, this is your solution. For number 11, this will be the solution. Okay, try these ones quickly. Give yourself 45 minutes to do them. Pause the video for 45 minutes, and after 45 minutes, press play. I assume that you took 45 minutes to do all of those, and these are solutions. If there's any problem that you would like me to explain, leave a comment and I will explain it. This is number 2. Number 3. Number 4. And number 5. Now we're going to be doing exponential laws of distributing exponents. Similar to the distributive property learned up to this point, that is under algebra. However, here we are not distributing bases, we are simply distributing exponents. That is multiplying the exponents. We can only distribute the exponents if inside the brackets they are not linked by addition or subtraction. So they must be linked either by multiplication or division. Otherwise, we cannot apply this law, okay? For instance, here I had in the numerator a to the exponent of m divided by b to the exponent of m. So I multiply each of those exponents. Note that inside the bracket, all the exponents will be multiplied by the outside exponent of 2. So that is why in the numerator, my exponent is m. I multiply that by 2. And my exponent in the denominator is m. I also multiply that by 2. And I ended up having a to the exponent of 2m divided by b to the exponent of 2m. The principle behind this is that both the exponents of the numerator and the denominator must be multiplied by 2, because both of them are raised to the exponent of 2, which means we're multiplying them twice. So instead of multiplying them twice and then adding the exponents, you rather just distribute the outside exponents. I emphasize this. Please do not distribute across addition and subtraction. I repeat, please do not distribute across addition and subtraction. And pay attention to the addition and subtraction. When I have a number that is multiplied by a negative number, it doesn't mean that between those two numbers there's minus. There is multiplication, I just multiply. But sometimes you'll have a number subtracted from a number, and there is no multiplication in between. Please note that multiplication will be expressed as a dot or simply the sign multiplication. Okay. The rules do not change before distributing. Make sure you simplify what is inside the brackets first. Before you distribute, simply make sure that you simplify what is inside the brackets first. All right. Let's check this out. How many exponents do I have inside the brackets? And by the way, am I allowed to even distribute? Tell me, why am I allowed to distribute? I am allowed to distribute because the bases inside the brackets are linked by multiplication. If they were linked by subtraction or addition, I wouldn't be allowed to distribute. Because they are linked by multiplication, I will count how many exponents I have inside the brackets. I've got 2m as well as 3n, so both of them will be multiplied by 2. All right, and this is what you will end up getting. Meaning that we're going to have a to the exponent of 4m times b to the exponent of 6n, sorry. All right, let's go to the next one. Try these ones. Just to give you a clue, if you are given a number, please note that the exponent of that number is 1. If it's not written, if the exponent is not written, the exponent will be 1. So in that case, in the first one, we've got 3 factors, which is 2 to the exponent of 1 times x to the exponent of 2 times y to the exponent of 3. So all those exponents must be multiplied by the outside exponent, which is 2. Are you even allowed to distribute the outside exponent? Yes, you are, because all of those are linked by multiplication. Okay, now let's do that. I'll give you around 12 minutes. Okay, just do those. You've got 12 minutes. Press pause for now and then come back after 12 minutes. Okay, let's do it quickly. Here I will simply multiply all the exponents, including the exponent of 2. Note that the exponent of 2 is 1, so all the exponents will be multiplied by the outside exponent of 2, okay? And that's how I expressed it. So you'll have 2 to the exponent of 2 times x to the exponent of 4 times y to the exponent of 6, all right? The next one, oh, 2 to the exponent of 2 is 4. I forgot that, okay? The next one, what are we going to get? 3 to the exponent of 3 times b to the exponent of 15 times b to the exponent of, a to the exponent of 15 times b to the exponent of -6. How did we get -6? -2 multiplied by -2 multiplied by 3 will give you -6. And 3 to the exponent of 3 will give you 27. Remember what I said earlier on, if your exponent is negative, you take the exponent and the base to the denominator, right? So I'll start by saying 3 to the exponent of 3 is 27, a to the exponent of 15, b with 6 will be taken to the denominator. Okay. Next one. Simplify what is inside the brackets first. I will simply apply the exponential law of division inside the bracket. So I'll be left with 2, a to the exponent of 2 minus 1. Note that the exponent of a in the numerator is 2. The exponent of a in the denominator is 1. So I will simply say 2 minus 1. And for b, I'll have 3 minus 2. So inside the bracket, I'm doing that all inside the bracket. So I'll have 2, a to the exponent of 2 minus 1, b to the exponent of 3 minus 2. So I end up having 2ab inside the brackets. Now you can start multiplying. You simply multiply the exponents, okay? So I'll end up having 2 to the exponent of 3 times a to the exponent of 3 times b to the exponent of 3. 2 to the exponent of 3 is simply 8. Okay, the next one. 3 to the exponent of 4 times c to the exponent of 20 times d to the exponent of 12, correct? Note that 3 to the exponent of 4 is simply 81. Let's go to the next one. R to the exponent of 15 times x to the exponent of 3 times t to the exponent of 6. That is correct. All right. What about this one here? Note that you might be tempted to apply the exponential law of division, failing to understand that you need to distribute the exponent in the numerator first, because that 3 is not the exponent of the entire fraction. It is only the exponent of the numerator. So you will simply take 3 times it by 2, 3 times by 3, and that will give you how much? M to the exponent of 6 times n to the exponent of 9. Then you apply the laws of division. So what are you going to have? M to the exponent of 2, which is 6 minus 4. Okay, so 6 minus 4 will be 2, and n to the exponent of 6, which is 9 minus 3. Brilliant. Try these ones. I'll give you 45 minutes. After 45 minutes, pause and then come back to check the answers after 45 minutes. All right. Check the answers here. Remember the rules, okay? Now here, I simply emphasize what I said earlier on. Anything that you raise to the exponent of 0 will be equal to 1. Anything raised to the exponent of 0 will be equal to 1, okay? In our next lesson, we're going to start with surds and do more. Please check out the next video tomorrow morning. Just check out the next video tomorrow morning. And for today, just go through what we went through and make sure that you understand everything we did today. Hozo.